Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Hi.
Oi! So they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome to today's session of Dynamic Programming Series, and I'm very pleased to see you all here. Can I please get a quick confirmation if my voice is clearly audible and if my screen is visible? All right, so hi Rishit, hi Naikaj, hi Abhijit. Thank you Rishabh, Nix and Abhijit for the confirmation. So let's just wait for a couple more minutes, okay? Actually, this session was supposed to be on Thursday and Friday, but due to some reasons, it has been preponed to Monday. All right, so that's why the session is being taken today, and the next two sessions will be taken on Friday and Thursday only. So we are discussing dynamic programming. And the topic that we are going to discuss today is matrix chain multiplication. Okay. So, all right, yes, Abhijit, we will be starting with the recursive course and then memorization. And then tabulation will be given as an assignment because once we have the memorization code, then to convert it to the tabulation, there is not much of effort that you need to do. You just need to create a table and you can enter the values there. So in today's session, we will be discussing the recursive approach and memorized approach, okay? First of all, recursive approach and then memorized approach, all right? Okay, so we are good to go with today's session. So let me start it. All right, guys. So today we are going to discuss this MCM thing. Again, it is a concept that is based on DP. All right. So let us first start with understanding the problem statement. Okay, so before discussing the problem statement, let me first tell you about what is this MCM thing. Okay. like based on this MCM, there are lots of questions that can be solved. Okay, so whenever there is a question that is based on MCM, all right, so there are certain steps that you need to follow. Now, what are those steps? The first step is, what basically happens in an MCM question is that whenever like an array will be given to you, like it can be anything, like it can be an array or it can be a string. Okay, that will be given to you. And what you basically need to do is, like, let us say the starting point is I, the ending point is j. There is a new variable that is being introduced here, and that new variable is k. So what happens is k is being iterated from I to j. Okay, we calculate the value of k. All right, like let us say we are starting k from k is equal to 0, okay, which is I, and you will iterate it till k is equal to n minus 1, which is j. Okay, and for every value of k falling in this range, you will get the value from the function, that what value we are getting when k is 0, when k is 1, and so on. And all those different values, based on those different values, you will be calculating your final answer. Okay, so like let us say if you have done the first round of iteration. Okay, so in the first round of iteration, let us say we have evaluated it for k is equal to 0. In the second round, we have evaluated it for k is equal to 1, and so on. We will keep on evaluating. And whatever answer we are getting, we will store it in a variable temp. Okay, and like you need to perform some operations on this variable temp to find out your final answer. Right, so the crux of this MCM, like how we are going to solve is, the first step is, whatever array and string is given to you, you first need to find out I, that is the smallest value of the array. Then you need to find out j, that is the largest value of the array, largest index value. Okay, and then after finding out these two values, you need to change k from the lowest value to the highest value, right? And then after changing k from in this range, you need to find out the value of k for the each round of iteration, right? And then whatever value you get, you need to perform a certain operation on those values to get the final answer. Okay, so basically what we are doing in MCM is that whatever an array is given to you, okay, we simply keep on breaking it, right? Like let us say I'm taking my k here. Okay, this is my k. Okay, so what we basically do is, you will calculate the values till this part, then you will calculate the values till this part, and then you will do certain operations. Okay, so let us say for the first part, the value will be like from I to k, and for the second part, the value will be from k plus 1 to j. Okay, you need to call your function recursively for these two parts, right? And then you need to perform an operation to get the final answer, right? So let me sum up. So the first thing that we are doing here is, there is one big array or string that is being broken into small parts. Okay, into two small parts basically. This is the process. Okay, the process while we use while solving the questions based on MCM. Okay, so one big array or string that is being broken into two smaller parts, and then second thing you need to do is find the value of I and j and iterate k from I to j. And what do I mean by iteration is, call the function recursively. Okay, you need to call the function recursively for I to k, and then from k plus 1 to j. All right, this is the second step. And then at the third step, what you need to do is apply certain operations see whatever value you get by after calling the function recursively for ik and k plus 1j, store them in a variable temp. Okay, which is your temporary answer. Okay, so apply certain operations on, okay, operations in the bracket, because there can be single operation as well. So apply certain operations on temp to get final answer. Okay, so these are the basic 3 steps that we are going to follow while solving the questions that are based on MCM. Okay. Sorry. Yeah. So these 3 steps. So can I please get the +1 if these 3 steps are clear to you all? And also, if there is any query or any confusion till now, please feel free to ask, because this MCM is like a new concept that we are starting today. So, okay, thanks, Abhijit. Means I haven't started the question yet. Okay, I'm just trying to make you understand. We will go step by step. Okay, we will not rush into this concept. Okay, we will try to understand it in a very good way so that the concept get very clear to you. All right, Rishit. So the third step is, like, let us say I have called the function. First time when I'm calling the function, let us say the name of my function is solve. Okay. So first time I will call it for I to k. Okay. And then I will solve the question, call the function for k plus 1 to j. Okay. Let us say the answer that I'm getting from here is temp, and like the answer, let not it be temp. We will use it later. Let us say the answer that I'm getting from here is A1, and answer that I'm getting from here is A2. Okay, so you can't return 2 answers, right? We need to have one single answer for the question. So how will you decide that whether you need to return A1 or whether you need to return A2? Maybe it can be that you need to return sum of A1 or A2, or either it can be you need to return the minimum of A1 or A2, or you need to return the maximum of A1 or A2. Okay, it can be anything. Okay, so these things that you have done, like doing the sum, finding the minimum, finding the maximum, these are operations, right? So when you will calling the function several times recursively, you will be getting multiple answers, right? So on what basis you are going to return the final answer, that is decided by the certain operation. Okay, so that you need to decide after reading the question, that what is that operation that you need to do, right? So on that basis you will return the final answer. So this is the third step. Like when you will perform the second step, you will get multiple answers, and to get the final answer you will perform a certain operation. Okay, is it clear now? Okay, you're most welcome, Rishit. All right, so is there is anyone who's having any sort of confusion till now, so that we can discuss it? Like MCM is a very easy concept. It may seem like in Geeks for Geeks also it is like a hard question, right? So it may seem to you like kind of having difficulty in solving this question, but if you will just try to understand from the very scratch, the concept will get very clear to you all, right? You all will be able to understand what we are doing. So yeah, can I please get more +1 so that we can move ahead towards the question? Okay, so as I can see, we have certain number of participants here, but the number of +1 are not equal to the number of participants that we have. Okay, so again we are having a +1. All right, so now let us move towards the question. Okay. All right. So the question that we are going to solve today is matrix chain multiplication. Okay. Okay, are you all guys, I hope, familiar with this fact? Like, let us say there is a matrix with dimensions A cross P, and then there is another matrix with dimensions C cross D. Okay, what is the first condition or the only condition we check to check that if these two matrices are compatible for multiplication? There is one condition that we check always. What is that condition? For the matrix multiplication, what is the one necessary condition that we check? Okay, so I guess it is a class 12 concept, 11, 12, like we studied there. No answers for this? Let me add a banner also. Yeah, okay, sorry, I guess my internet was lagging. Okay, so the condition that we check for the compatibility of matrix multiplication is B should be equal to C. Okay, the number of columns of first matrix should be equal to number of rows of second matrix. All right, so we have the correct answers from Abhijit, Rishit, Apurva, Naikaj, and Sandeep. And just a second, Naikaj, you are having a -1 there. So, like, are you clear with the concept, or is there any confusion that you are having? Do let me know so that I can explain it to you again. Okay. Yeah, so we are discussing matrix chain multiplication, all right? So the first condition that we check is, and the only condition that we check is B should be equal to C, right? All right, so if we are multiplying these two matrices, then what is the dimension of the new matrix that we are going to get? A cross T. That's perfectly right answer, Abhijit and Rishit and Nix and Sandeep. All right, Naikaj as well. So that's the right answer. So we are clear on this part that what is matrix multiplication. Okay, how matrix multiplication is done. First of all, we need to check that number of rows must be equal to the number of columns must be equal to the number of rows, and the dimensions of new matrix are going to be A cross T, right? Okay. So now what is happening in this question is, like, let us say there are multiple matrices that we need to multiply. Okay, are you guys familiar with the concept cost of multiplication? Like, I will tell you what it is. Let us say we have four matrices A, B, C, D. Okay, and let us say we are multiplying them, right? Okay, and let us say you are multiplying two matrices. Let us not take four matrices. Okay, so there are two matrices that we are multiplying, A and B. The dimensions of A are A cross B, dimensions of B are C cross D. Okay, so whenever we multiply two matrices, there are certain multiplications that we perform, right? So what is the total number of multiplications that are performed while multiplying two matrices? What is the total number of multiplications? Okay, Nikit. So that is B into C. Aren't B and C the same? Like, if you are multiplying these two matrices, then B and C's are going to be the same. All right. Only then you can multiply them. So whenever we multiply two matrices, there are two operations that is happening. That is addition operation and multiplication operation. Okay. So for multiplication, how do you calculate that? What are the total number of multiplications that are taking place? So that is basically, we don't have any answers. Okay, so let me tell you that. So the total number of multiplications that is there for the when we multiply two matrices is A cross B cross T. Okay, that is the total number of multiplications, and that is also known as the cost of multiplication. Okay, so basically the question demands here is that whatever this cost is, you need to minimize it. Okay, all right. So if I redefine the question, then it will come out to be like a matrix is given to you, several matrices are given to you, and what you need to do is minimize the cost of multiplication. Okay, by minimizing the cost of multiplication, what I exactly mean is, yeah. So what you need to do is you need to multiply these matrices in such a way All right, so that the total number of multiplications that is happening, that will get reduced. Okay, like let us say one matrix is 5 cross 4, other matrix is 4 cross 8, other matrix is 8 cross. Okay, let me take an example. This is not a good example. Just a second. Okay, so if these portions are weak, then like I'll try my best to make it very clear to you. If at any point you get stuck, please feel free to ask. All right. So let us say an array is given to you, right? That is 40, 20, 30, 10, 30. Okay, this is an array that is given to us. Okay, and what does this array denotes is, this array basically denotes, this is our input. Okay, and this array basically denotes the dimensions of matrices. Okay, and how it is denoting the dimension? It is like there are 4 matrices. Okay, the dimension of matrix A is 40 cross 20, the dimension of matrix B is 20 cross 30, the dimensions of matrix C is 30 cross 10, and the dimensions of matrix D is 10 cross 30. Okay, so these are the 4 matrices that are given to us, and you need to find out that in what way you can multiply them so that the cost of multiplication is reduced. Okay, so in output you need to return that cost. All right, so for output, what we are going to do is, the most optimal way to multiply them all is, first of all, we are going to multiply B cross C. Okay, and then after that we will multiply it with A, and then after that we will multiply it with D. Okay, so that will give you the minimum cost. And what is that minimum cost? When you will multiply B cross C, the cost that we are incurring is 20 into 30 into 10, right? After that, when you will do a multiplication of this matrix with A, all right, Shishir, so that's great. It is clear to you. So when we will do the multiplication with A, what is the total number of operations that you are going to get in this case is 40 into 20 into 10. Okay, and then after that, when you will do the last multiplication, in that case, the total number of operations you will be having is 40 into 10 into 30. Okay, so this will sum up to whatever integer. Let us say this is coming out to be an answer. Okay, so this is the minimum number of operations, multiplications that is done, right? So that is why the answer, let me check the output. The output to this question will be 26,000. That is the minimum number of operations that is required so that the matrix multiplication is done in the most efficient way, right? So in input, an array will be given to us, and in output we need to return an integer. That is the total number of multiplications required. All right, so is the input and output clear to you all? All right, Abhijit, thanks for the confirmation. Rest other, okay, Rishit, input and output is clear to us. Now let us see what we are going to do next. So let me start. Let us say this is an array that is 40, 20, 30, 10, 30. Okay. What is the size of the array? That is n. In matrix mul, we have all column of A matrix with row B matrix, right? Like, yes, rows of A matrix are multiplied with columns of B matrix. Okay. So if the size of an array is n, then what is the total number of matrix that we have? So, okay guys, tell me what is the total number of matrices we have in this array? N minus 1. That's great, Aman. Yes, Rishit. Correct, everyone. This is N minus 1. Okay. And what are those matrices? That is A having dimension in this 2. Then we have B. This is dimension. Then we have C, for which this is the dimension. And then we have D. Okay, this is the dimension, right? So if the size of the array is n, then the number of matrices in it are going to be n minus 1. All right, Abhijit, yes, that's the precise answer. It's 4. Okay. Now, how we are going to, let us now try to solve this question. So basically, if the array is A, B, C, D, okay, so we need to find out that on which part we need to break the matrix, right? You need to find out that if you should break the matrix from here, right? Or if you should break the matrix from here, or if you should break the matrix from here, okay? So basically, we are changing the value of K starting from I to J, right? You are trying at every point, like if the matrix multiplication should be done from I to K, and then for the next you are trying it for K plus 1 to J. You are trying to break it at, you are trying to break this array at every point, right? You will first of all check that if this partition is going to give you the minimum, or if this partition is giving you the minimum, or if this partition, right? So here we have a variable K that we are basically varying from I to J, right? So is this clear how we are going to use MCM in it, like how MCM format is being used? Okay. Now you need to find out that from which point to which point the value of K will be varied. Okay. So if you will notice, this is 40, 20, 30, 10, 30. Okay. So if you will notice inside this matrix, what is happening is that dimensions of a matrix is, dimension of matrix is coming out to be, this was A, B, C, D. So the dimension of matrix is coming out to be array of I minus 1 into array of I, right? In this way, we are getting the dimensions. So now tell me, if I start from if I start value of I from 0, will I get the correct values, or will I be able to get the result? Yes, Nix and Rishit and Aman, that's correct answer. I'll not get the correct answer, okay? If I start I from 1, so let us discard this. Okay, Abhijit, you didn't get the dimension part. So by, yeah, like as Nix correctly said that, because we are accessing I minus 1th element, okay? So what I meant by the dimension was that the dimension of matrix A here is 40 cross 20, right? Now this is, let us say 0, 1, 2, 3, 4. So what is the dimension of A? Let us say if we are, like, if you see at whatever index you are starting, at whatever index you are standing, okay, 1 minus from that index and that index, okay, when both of them are multiplied, you get the dimensions of the matrix, right? Like let us say this is our matrix A. So what is the dimension of matrix A? A is on this, and like this, the current index, and 1 minus current index. Okay. In that way, we are getting the dimensions, right? So that's why we can say that the dimension of matrix is given by array of I minus 1 into array of I. Now, if you start your I from 0, then in that case, what will happen? You can't access the 0 minus 1. That is the minus 1th element you can't access, right? So what we need to do is we need to start our I from 1. Right, so if you start our I from 1, then the dimension of matrix A will be array of 0 into array of 1, okay, which is 40 into 20, right? So as it is correctly mentioned here, as we can see, the dimension of matrix A is 40 cross 20 only, right? So the value of I will be starting from 1. Start from the first index, exactly, Nikaj. Now tell me one more thing. What could be the value of J? Till what point you can iterate J so that you can get the correct answer? N minus 2. Okay. Exactly, Aman. That's the right answer, N minus 1. And Okay, so we are having n minus 2 here. So let me clear this doubt. If you will, here we have the value of n as, the value of n is given as 5 here. Okay. Now, all of you guys are saying, like, for those who are confused with n minus 2 and n minus 1, let just tell me one thing. If you will iterate j till n minus 2, that is 3. Okay. So, if the last value of j is 3, will you be able to get the dimensions of matrix D? Because the dimensions of matrix D are array of 3 into array of 4, right? So, how you are going to get this 4 if the last value of j is going to be 3? Okay, so array at n is not present, n is not an accessible element. Like if at the size of the array is n, then you can't access the element at the nth position, right? So basically, yeah, exactly. Now you got it. Basically, the last point of j will be n minus 1. Okay, so now we understood that I is starting from 1 and j is ending at n minus 1, right? So basically, thus our k is going to iterate from 1 to n minus 1 closed bracket. Okay, it will iterate at all these positions. Clear? The range of k is clear. Okay, so now we have figured out the value of I, we have figured out the value of j, and we have figured out that on which range our k will iterate. Okay, so after doing all these three things comes the most trickiest part, that is you need to analyze that what operations you are going to, like if you will iterate k from 1 to n minus 1. Okay, let us say the value of k is 1, you will get an answer. Okay, we will store it in temp. The value of k is 2, you will get an answer. Okay, when the value of k is 3, in that case as well you will get an answer. You need to find out that like on the basis of what operations you will get the final answer out of these three answers. Okay, so what we can basically do is, what we are basically doing here is, basically for int k is equal to I, k is less than is equal to j, and k plus plus. Okay, what we are doing is we will store the, let us say we have a temporary variable here. Okay, we will call the recursive function solve. Okay, is the screen frozen? Can anyone please confirm if the screen is frozen? Anything wrong with this? Okay, let me reshare. Okay, let me see what's the issue. Okay guys, just a second, I will just reshare. Okay, so now I am frozen. Very confusing. I mean, let me just reshare again. Is everything fine now? Okay, so now nothing is frozen, right? Neither I am or not the screen. Okay, all right. Thank you, everyone. So basically, what we are doing here is we are iterating k from I to j, and this is k plus plus. Basically, you can do a for loop, and then what you need to do is call the solve function for array, whatever is given, starting from I, ending at k. Okay, then call the solve function for array starting at k plus 1 and ending at j, and then you need to sorry you need to find out the operations that are being taken, excuse me, Okay, so you need to find out the operations that are being taken place. Okay, just a second. So what will be that operation? You guys will be able to clearly see it. Let me show you how. Let us say if this is the matrix. Okay, A, B, C, D, which was basically 40, 20, 30, 10, and 30. Okay, now let us say that my K lies here. Okay, this is my I. All right, and this is my K. Let us say I've broken the array like this, and this is my J. Okay, so in the first function what I'm going to do is I'm going to call the function for I to K. All right, guys, now tell me one thing. If this is one matrix multiplication you are doing, that is like you have called the function for I to K, right? Now what is the dimensions of the matrix that you will get while performing the operations? Okay, how we are going to get this is, when you will multiply matrix with these two dimensions, 40 cross 20. Did I miss something? Yeah. And with these two dimensions, that is 20 cross 30. Okay. So in that case, the final dimensions that you will be getting is 40 cross 30. Okay. And in this, like for the first part here, we have broken our matrices into two parts. Okay, this is the first part, this is the second part. In first part, the multiplications that are taking place are 40 cross 20, 20 cross 30. Okay, so the final dimensions will be 40 cross 30, right? Now in the second part, the multiplications that is taking place is 30 cross 10 and 10 cross 30, right? So what will be the final dimensions? The final dimensions in this case will be 30 cross 30. Okay. And at the end, what you will need to do is you will need to multiply these two matrices also. So what will be the final dimensions after multiplying these two matrices? That is going to be, sorry, the total number of operations. What will be the total number of operations? That is going to be 40 cross 30 cross 30, right? Exactly, Abhijit, that's the right answer, 3600. Okay, so basically what I told here is that let us say I have partitioned my array like this. Okay, this is the partition, this is I, this is K, and this is J. So now if this is the first part, what are the multiplications that are taking place at first part? 40 cross 20 and 20 cross 30. The final dimensions will be 40 cross 30. The multiplications that are taking place in second part is 30 cross 10 and 10 cross 30. Okay, so the final dimensions will be 30 cross 30. Okay, so after this, if you will multiply these two matrices, then what will be the final dimensions? The final dimensions will be 40 cross 30. Okay, and the total number of operations will be 40 cross 30 cross 30. Cool. Now you all tell me, what is this 40 cross 30 cross 30? If you Exactly, Rishit. We have to add the cost of multiplication also. So here I am explaining that how we are going to derive the cost. Okay. So this is the total number of operations that we are getting after multiplying the two matrices. So now you let us say this is cost. Okay. So as Rishit has termed it as cost, so we will term it at cost only. So this is operation. So like, okay, guys, tell me what is 40 here? If you are multiplying it with 40 cross 30 cross 30, this is I, this is K, this is J. What is 40? If I want to access 40, what can I write? I minus 1. Okay, that's the correct guess, Aman. And Rishit, yes, that's the right answer. Yes, Abhijit. So cost, basically, it is array of I minus 1 into what is 30? Yes, Naikash, that's right. What is 30 and what is another 30? Okay, tell me both of those things. Okay, it is a of k and the last 30 is array of j. All right. So this is the cost basically that we are getting. So everyone, let me tell you, if in the for loop when you are iterating k for k in I to j, okay, so basically the answer that you are going to get is in temp. First of all, you will call the function for array I to k, plus you will call the function for array, because we need to add the operations, right, k plus 1 to j plus the cost. And what is that cost? Array of I minus 1 into array of j into, sorry, array of k into array of j. Okay, so this is the operation that we are going to perform. Now everyone, please let me know, is this operation clear to you all? Basically, as I said, what we will do is we will try to break the matrix at several parts. Okay, if for that we are the cost for adding the result of the two solve calls, the cost is for adding the result of the two solve calls, right? Yeah, basically the cost is that in the solve 1 you have multiplied the matrices from I to k, in the solve 2 you have multiplied the matrices from k plus 1 to j. Now what is the cost that you will get when you will combine these two answers? Okay, so for that we have used the cost. Okay, the cost is, yeah, as you said, it is the adding result that you will get from these two calls. Basically, whenever you are multiplying two matrices, the two part of matrices, okay, the two part of arrays, whenever you are combining them, what is the final cost that you are going to incur? That I have written here. Okay, so yeah, that is what. Now let me quickly write a recursive call for this so that it will become more clear. Let us say the function is int solve. Okay, and we have an array here. We have I index, we have j index. Okay, as this is going to be a recursive function, can anyone help me with the base case? Because it is a recursive function, I is equal to j. Okay, yeah, that is not valid if I and j are k is equal to n minus 1. Okay, we are not having k inside our function. In the function parameters, we don't have k. Okay, basically, if we have I greater than is equal to j, then in that case we will be returning 0. Okay, because that condition is not valid, right? I can't be greater than j. Okay, so that is our base condition. Now second, we will run a for loop for int k is equal to I, k is less than is equal to j minus 1 and k plus plus. What we will do is we will store our temporary answer. Okay, and how it is going to be? Solve function for array ik plus solve function for array k plus 1j plus array of I minus 1 into array of k multiplied by array of j, right? And let me declare one more variable here, that is int answer. That is going to be our final answer, initializing it with int max. Okay, now we will need an eraser here. Yeah, so this part is done. Okay, you are having a temporary answer. How you will update your permanent answer? That is, answer will be minimum. Okay, of answer, comma, the current answer that we are getting. Okay, so once you have calculated it, at the end you can simply return answer. Okay, and then we can have a closing braces. All right, is this code, recursive code, clear to you all? Please look at it very carefully. If at any line any confusion is there, please feel free to ask. Because like understanding the memoization and tabulation is not that tough. This recursive code is the only concept. You can easily modify it to memoized version and tabulation version. Yeah, so can I please explain the base case condition? Of course I can. Let me show you. Basically, let us say that this is an array. Okay, I is here, j is here. Okay, we are, let us say, whenever we are solving this for array I to k, k plus 1 to j. Okay, so basically the value of k will be varying from here to here. Okay, now let us say the current value that you are at, if let us say I is equal to j, which means that there is only one index on which you are operating. Okay, so if you have only one index, tell me, in that case, will you be able to get the dimensions of a matrix for only one base, only one index? No, exactly. We are not able to get the dimensions. All right. And let us say if after like incrementing this variable, I is like getting out of bound, it is coming as greater than j. What is j? J is basically the last index. Okay. J is the last index. So if j I, the value of I, basically you can say it as a value of k, because k we are starting from I and ending it at j, right? So if at any point if value of I is becoming greater than j, and j is the last index that we have, so is it also a valid case? Basically you can the function will get terminated at this point only when I becomes equal to j, but also when I is greater than j, that is also not a valid case. I can't be greater than j because j is the upper limit. Okay, you can't cross the upper limit. So that's why I have mentioned the base case here, that if I is becoming greater than or is equal to j, we will simply return 0. Okay, so now everyone please look at this code. This is our base case. This is iteration of the loop. Okay, we are breaking the array in different parts. Can we interpret the case as when we have one matrix, so we can't multiply, so not a valid case? No, we can't interpret as we have only one matrix. For having one matrix also, you need to have two indexes for its dimensions, right? You need to have, if this is 40 20, okay, if only one matrix is given to us, even then it has two values, right? You need to have two indexes for its dimension. If I is equal to j, it means that you are only at say index 2. So index 2 will have only, let us say it is having only 40, right? So how you will find out the dimensions of it? Dimensions are not able to calculate it. Okay, you will not be able to find the dimensions. So that's why it is not a valid case, because we need at least two index. Okay. So yeah, this is the base case. This is the iteration that we are doing. This is the operation that we need to perform. This is the operation that we are performing for the final answer. Okay. All right. Thank you for all those who have understood the explanation. So yeah, this is a recursive code. Please give me a quick +1 if this code is clear to you all. This recursive code. And anyways, this is having a lot of time complexity, so we are not going to deal with this. Now, if the recursive code is clear to you all, so if we want to go from recursive to memoization, what is the only one thing that we need to do? What makes a recursive function a memoized function? Thanks Rahul, Aman and Rishit for the confirmation. Exactly, Rishit. We store the previously calculated arrays. So that is what we exactly do. We will basically create a T array for any dimensions, let us say 100, 100, based on the constants that is given. Initialize it with -1, okay? Like fill -1 in it. And now in the, like whenever you are returning an answer, here we are returning answer. So before returning, just store it inside the T array, okay? And also before at every step after the base case, we need to write that we need to check if T of ij is not is equal to -1, okay? And then at the last you need to write return T of ij is equal to answer. Then here we will simply return T of ij. And other than these two statements, all the snippets will remain same, okay? Exactly, everyone. That's wonderful answers that all of you have given. Nikaj, we store previous calculated rest, and when rest overlapping, then we return the DPI directly. That's perfectly right. Then Rishit had the correct answer. Aman has given the correct answer. Abhijit has given the correct answer as well. So, like, okay, all of you guys have given the correct answer. So, I'm pretty sure all of you are now clear about the concept. Now it's time to let me show you the code for this question. So I will just share my screen, and here it is. So yeah, everyone, this is the code. This is the memoized code. You can easily convert it to the tabulation approach as well. You just need to write down a for loop, okay? So what we have done is that I have created a variable 2D DP array, that is T. I have initialized it globally, and then I have filled it with -1. I have called the function starting from I till n -1, okay, as we discussed. And then this is the code that I have written. So if there is any confusion in this code, everyone please let me know in the chat section. That's great, Aman. You are not having any confusion in this question. That's nice to know. All right, Abhijit, it is clear. Okay, so I'm very happy to see this, that the question is clear to you all. Please to see Nix and Rishit as well. Okay, guys, so that is the code for this question, okay? And all of you can try to write down the tabulation approach as well. There is nothing much in that. All right, so that was all about the concept that we covered today. That was matrix chain multiplication. So if there is any confusion, post it in the chat section, or if there is no confusion, then do give a +1, or like, okay, as I can see, all of you have written clear. All right, so the next session we are going to have it on Thursday and Friday, wherein we will be having practice sessions. Okay, we will do some of the questions based on DP. All right. So that was all about today's session, guys. I see no any confusions here. So I guess we are good to wrap up. Okay. All right, everyone. Thanks for joining this session. Stay safe, take care, and keep up the hard work. Good night, everyone. Okay, so yeah, Aman, the famous MCM questions are some of the famous MCM questions are scramble string questions, the egg dropping problem, and the palindrome partitioning as well. Okay, you can try solving those questions. Your concept will get more clearer. All right. So yeah, bye everyone, and take care.